The invention of zero. The number zero is now very commonplace, but as it turned out, it took a long time to develop, and most early civilizations never even got to it. Not even the math-savvy Greeks. This is how it went. A very early way of counting is to simply make markings on objects, such as these notches on this bone from 44,000 years ago. But with a line for each unit, this method becomes ineffective for large numbers. Even to write a number like 25 in this way takes a long time to write down and a long time to read off. To solve this problem, the Babylonians invented place-value notation, which we still use today, although the Babylonians used a more complicated form. But let's take as an example the numbers of today. Take the number 111. The third one means just 1, but the second one actually means 10, and the first one means 100. The value of the number depends on the position of the number, and that is why we call it positional or place value notation. And this is a way more efficient way of writing. And now back to zero. Surprisingly, place value notation almost forced the Babylonians to invent the zero. For how else can we differentiate between, say, the numbers 1 and 10? We require that zero behind it. The Greeks, although great mathematicians, were not at all comfortable with zero. And this was because they linked their numbers to geometric shapes. And since a line, for instance, cannot have length 0, they considered the number 0 an absurd idea. The Indians, however, had always been comfortable with the idea of zero, with nothingness. Perhaps because emptiness had always been an important part of their religion. And this somehow seemed to make them unafraid to experiment with the strange properties of zero. And they were the only early civilization to do so. They discovered that the number times 0 is always 0. And also that the number divided by 0 gives us infinity. Another concept that only the Indians were comfortable with. It was this numeral system of the Indians that was eventually introduced to the Arabs in the 9th century by a man called Al-Khwarizmi. I discussed him in the previous lecture. And in the 13th century, the system was introduced to Europe by the Italian mathematician Fibonacci. And let's now dive into this wild tale. Hey, good to see you. This is Stephan, author of In Search of the Sublime. On this World History channel, we'll trace humanity's relentless pursuit of scientific truth, moral excellence, and enlightenment. You'll meet anyone from Mesopotamian astronomers and Indian yogis to Greek philosophers and Enlightenment scientists. And you'll meet them firsthand using primary sources, giving you valuable insights that transcend the surface-level understanding you get on other channels. So go check it out for yourself. Let's start. Let's start with some background. Counting systems have existed for tens of thousands of years. Take for instance the carving on the Lebombo bone, dated around 44,000 years ago from Swaziland, southern Africa. The carvings on this baboon bone show 29 notches, suggesting that it was used to count something, although we're not sure what. And here we see a wolf bone of about 30,000 years old from the Czech Republic, and this shows 55 notches. First we see 25 notches, then 2 long lines, and then 30 notches. And since both values, 25 and 30, are multiples of 5, it has been suggested that the person who made this counted in fives, which is sensible since we have 5 fingers. As expected, these prehistoric people had no symbol for zero. That simply wasn't necessary. If you want to count coconuts or days, you don't need a zero. The Egyptians moved to a somewhat more sophisticated model. They had values not just for 1, which just as in the prehistoric case was a straight line, but also symbols for 10, 100, etc. You can see these symbols on the left. And in this notation, this number depicted here is equal to 231, we have 2 symbols meaning 100, 3 symbols meaning 10, and 1 symbol meaning 1. So this is already a more effective way of writing, although there still is some unnecessary repetition. It takes 1, 2, 3, 4, 5, 6 symbols instead of 3 that we use today. And on top of this system also had no symbol for 0. Interestingly, however, the Egyptians did have a symbol for nothing, or nuffer, and the hieroglyph used for this, by the way, means something like beautiful or complete. Around 1700 BC, they used this symbol for bookkeeping for the royal court to denote no money. Income and expenses were subtracted, and in some cases that left 0 money, or nuffer. And in architecture, nuffer was used to denote the ground level, for instance of a pyramid. The layers of stone of a pyramid, and also the foundational layers below the ground, were counted in cubits above nuffer and cubits below nuffer. The Babylonians invented the more advanced system. It is getting used to this system, for it is a base 60 system instead of the base 10 or decimal system that we have today. We count in ones, tens, 100 and 1000s, etc. But the Babylonians went from 1 to 60 times 60 is 3600, etc. And it is a bit of a mystery why they did it, but it could be because 60 is very easy to divide. You can divide it by 2, by 3, by 4, by 5, by 6, by 10, etc. To write these numbers down, the Babylonians used wedges, which were just impressions into clay, and a wedge was equal to 1, and they also used angled wedges, and this stood for 10. And they then combined these numbers and counted up all the way to 59, 1 unit before 60, just as we counted till 9, 1 unit before 10. At 60, a new position opened up, because as I've told before, they used that place value notation. And at this new position, every wedge was equal not to 1, but to 60. So 61, for instance, was written with 1 wedge for 60, and then 1 wedge for 1. So 1, 1 becomes 61 in this system, while in the modern case, of course, it becomes 11 instead of 61. The upside of this new system was that you can write very large numbers with a minimum of symbols. Let's compare. Take the value 3662. In the prehistorical case, that would require 3662 scratches. The Egyptian system would be a lot better. It required 3 symbols for 1000, 6 for 100, 6 for 10, and 2 for 1, giving us a total of 17 symbols to write this number down. Much better, but still not the best. And then we go to the Babylonian case. It requires 3 symbols, a 2 for the value 2, then in the second place a 1 meaning 60, and then in the third place a 1 meaning 3600 or 60 times 60. So a huge improvement. But there was also a problem with the early Babylonian system. How do we differentiate between, say, 61, which is 1 wedge and another wedge, a 60 and a 1, or the value 3601, which requires 1 3600, 0 60s, and then 1 1. So it is a wedge, nothing, and then a wedge. But as you can imagine, these symbols look very much alike. 61 has 2 wedges, and 3601 also has 2 wedges. Well, they first solved this problem by leaving a space when a position had no entries. So in this case you have wedge, space left open, wedge. And around 300 BC, that space was replaced by 2 diagonal wedges, which you can see here. And just like the space, they were used as a placeholder, meaning no entries. So to solve this problem, they were almost forced to invent a 0. And by the way, this also happened to the Mayans in South America, who also used a place value notation and then somehow ended up with a 0. Yet the 0 obtained in this way was just a placeholder to complete their number system. And in fact, in this point, that 0 or placeholder wasn't even considered a number. And one definitely didn't calculate with that placeholder. It just meant no entries. Now to the Greeks. The Greeks generally took over the inefficient system of the Egyptians. However, for astronomy they used the Babylonian system. And here they also required a placeholder 0. And for this they used the omicron, which is a circle, similar to the symbol for 0 today. Although we're not 100% sure that our modern 0 is derived from this omicron, because the Indians also used a circle for 0, and that 0 eventually ended up in Europe in our own system. But there is a possibility that when Alexander the Great entered India, he took this system with him, and in this way the circle ended up in India, and then later was transported again to the West. But there's no direct evidence for this. Now, while Egyptian math had been mostly practical as an aid to bookkeeping or architecture or for measuring land, the Greeks, who were abstract thinkers, saw numbers as divine, as godly, and therefore of interest to study in and of itself. Yet the Greeks were unable to divorce numbers from geometry, the study of shapes. So, for instance, the number 2 for them often meant a line with length 2. And 2 times 2 equaling 4 meant a square with sides 2 and area 4. But since there are no lines with length 0 or squares with area 0, they could simply not conceive of a 0. And by the way, the same holds true for negative numbers. You cannot have a line of negative length, and therefore they also did not consider negative numbers. In fact, when they performed a calculation that would lead to either 0 or negative numbers, they would simply write that the solution to that problem was absurd or impossible. It just didn't exist. Later in Europe, the absence of 0 caused a strange problem in the calendar, by the way. When trying to calculate the right dates for Easter, a man called Dionysius Exiguus, who lived in the 6th century BC, placed Jesus' birth, so the start of the Western calendar, not at 0 AD as we do today, but at 1 AD, because there was no 0. And this also meant that his calendar went from 1 BC immediately to 1 AD, skipping the 0 AD in the middle. And this had some annoying implications. For it would mean, for instance, that the period between 5 BC and 5 AD was not equal to 5 plus 5 is 10 years, but because we had no 0, it was 9 years instead. And if we're talking about 100 years after the birth of Christ, in this system, starting at 1, this would get us to 101 AD instead of 100 AD. But all this was very different with the Indians. From the 3rd century BC, the Indians still used a simple system, the Brahmi numerals, which we first found on the pillars of King Ashoka. This system has separate symbols for 1 to 9, also for 10 to 90, and also for 100 to 900. So a number such as 342 would require 3 symbols, a symbol for 300, for 40 and for 2. But at this early stage the system did not have a 0, and also it wasn't proper place value notation. For instance, the number 111, which in our system is 111, was still 3 different symbols in their system, because they used a different symbol for 1, for 10 and for 100. From the early days, the Indians were also very fond of large numbers. Already in the very early Yajurveda, from roughly 1000 BC, very roughly, we read of the names of various powers of 10 up to the 12th power. That is a 1 with 12 zeros behind it. While the Greeks only had words up to the 4th power. That is a 1 with 4 zeros or 10,000. And the story the Ramayana, from very roughly the 5th century BC, even had names all the way up to 10 to the power 62. Numbers they never actually needed in their everyday lives. But for them, these large numbers had some divine meaning. But since this system already worked with powers of 10, that is with 1, 10, 100, 1000, 10,000, etc., it was a small step to place value notation. and in this case place value notation in a base 10 or a decimal system, just as we use today, which is definitely an upgrade from that base 60 system of the Babylonians. And indeed, already in the 2nd century AD, the Buddhist philosopher Vasumitra writes of counting pits, which worked with place value notation. We read, when the same clay counting piece is placed in the place of units, a pit that counts in ones, it is denoted as 1, but when it is placed in a pit for 100, it means 100. And you can imagine a number of pits and you throw pieces of clay in there. And in this way you can easily count in place value notation. And in a commentary on the Yoga Sutra in the 5th century AD, we read, just as the same sign is called 100 in the hundreds place, 10 in the tenth place, and 1 in the units place, so is one and the same woman referred to differently as mother, daughter, or sister. Quite a curious, interesting analogy. And in the 3rd century AD, another place value system was also developed that used words instead of numbers. For instance, Veda Tooth Moon stood for 132-4, and Vishnu Hook Moon stood for the year 269 AD. The 0 was eventually added as a placeholder in an evolved version of Brahmi, which is known as Gwalior, the Gwalior system. And this system also added that place value notation that the Brahmi system also didn't have. And the numbers of this Gwalior system look strangely familiar. For instance, here we see the number 270, which was written down in 876 AD. And it is almost the same as we write the 2, the 7 and the 0 today. And we even have earlier cases of this number system in Southeast Asia that was by then under Indian influence. For instance, in Cambodia, in 683 AD, we see the number 605. For a while, by the way, it was assumed that the Bakshali manuscript, which was then dated to the 3rd century AD, contained the first Indian symbol for 0. They used a dot. But new tests from last year, 2024, dated instead to between the 9th and 11th centuries. So it is no longer the earliest 0 that we have. But to remind you for a moment, the 0 as a placeholder in that Gwalior system was itself nothing new. The Babylonians already had a 0 as a placeholder many years before. But then the Indians added something even more profound. In contrast to the Greeks, the Indians were very comfortable with the idea of nothing, the void, as it was baked into their religion from the start. And as a result, it is only natural that the 0 as a legitimate number that one could calculate with, and not just as a placeholder, would develop in India, and India alone. Already in the Rig Veda, from roughly 1500 BC, we read, in the earliest age of the gods, existence was born from non-existence. A very abstract way of thinking about nothingness. And we even write, even more paradoxical, there was neither non-existence nor existence then. There was neither the realm of space nor the sky which is beyond. What then stirred and where? The text then asks. So here we see them at this very early stage, even comfortable with illogical paradoxes. And this would definitely help with their mathematics. And in later Hinduism, Jainism and Buddhism, all Indian systems of religion and philosophy, nothingness even became the goal of their spiritual quest. It was believed that enlightenment could be achieved by making the mind empty through meditation. And in Buddhism, by the way, the same word for empty was used here. That was also used for their word for 0. And they believed that this state of meditation made them at one with the nothingness that was at the base of the universe itself. On top of this, the Indians also didn't tie their numbers solely to geometry as the Greeks had done. And these things together freed the way for the 0, and by the way also for negative numbers. Suddenly one could do 2 minus 2 is 0, and 2 minus 3 is minus 1. Two equations that were deemed absurd by the Greeks. And playing with this, the Indians came to see 0 as a legitimate number located between -1 and 1. And they might have come up with this as follows. If you do 2 minus 1, you end up with 1. If you do 2 minus 2, you end up with 0. And if you do 2 minus 3, you end up with -1. So here we get a counting line going from -2, -1 to 0, and then to 1, 2, etc. And this, by the way, started in the 7th century AD with the mathematician Brahmagupta. For the first time, he allowed for negative numbers and also for the 0 as solutions to equations. And he also showed how to calculate with them, making 0 here not just a place number or a symbol for nothing as it was with the Egyptians, but a real number on the same footing with the other numbers. Some of his rules read, the multiplication of a negative and a positive is negative, of 2 negatives is positive, and of 2 positives is positive, which give the correct rules of multiplying with negative values. And then about 0, the product of 0 and a negative, or of 0 and a positive, or of 2 zeros is 0. And these rules are also correct. But interestingly, Brahmagupta still had no idea what to do with 0 divided by 0 or 1 divided by 0, which he assumed in his text to be 0, but this was a mistake. Only later did the Indians realize that 1 divided by 0 is equal to infinity. Bhaskara in the 12th century wrote about this. This fraction, of which the denominator is a 0, that is a number divided by 0, is termed an infinite quantity. And then he connected 0 and infinity to the divine, stating that 1 divided by 0 is, quote, as infinite as the god Vishnu. And about adding numbers to infinity, he writes, there is no alteration if I add a number to infinity. It's still infinity. Though many numbers may be inserted or extracted, as no change takes place in the infinite and immutable God. And indeed, we still believe today that infinity has these weird qualities that are unlike any other number. And the Indians were the first to discuss this. The Hindu numerals eventually entered the Arabic world in the 9th century AD. A man named Al-Khwarizmi, my previous lecture is about his work, wrote about the Hindu numerals in his work On the Calculation with Hindu Numerals. And it was this system that finally ended up in Europe. And that is why we sometimes call the Hindu numerals the Arabic numerals. But since they originated in India, I prefer the Hindu numerals. Al-Khwarizmi did explain them beautifully. He wrote, we have decided to explain Indian calculating techniques using the 9 characters, that is 1 till 9, and to show how, because of their simplicity and conciseness, these characters are capable of expressing any number. A very good summary of the Hindu numeral system. And then he adds, the system also includes a 0, which he called, quote, the 10th figure in the shape of a circle. And by the way, the Indian word for 0, sunya, meaning empty, turned into sifr in Arabic, zephyrus in Latin, and eventually 0 in English. And by the way, that word sifr in Arabic also turned into cipher, which became cipher in French and cijfer in my own language, Dutch. And cipher, by the way, eventually became a synonym of the word numbers, not only referring to 0 anymore. And finally, it was a mathematician named Fibonacci who introduced the 0 and the Hindu numeral system to the West in 1202 in his book Liber Abaci. And in this work he showed how useful the Hindu numerals were for complex calculations. And soon merchants and bankers from Italy caught on, and then the idea quickly spread throughout Europe. And thus unfolded the strange history of 0. Thank you so much for watching. If you want to know more about the history of mathematics or any other topic from world history, then read my book In Search of the Sublime. You can read it completely for free on worldhistorybook.com, or you can buy a physical copy on Amazon. Thank you so much for watching. Bye bye. this was very different with the Indians.
But all this was very different with the Indians.
But all this was very different with the Indians.
But all this was very different with the Indians.
But all this was very different with the Indians.
But all this was very different with the Indians.
But all this was very different with the Indians.
But all this was very different with the Indians.